Hello friends, welcome back. Our next task is to find out what are the stresses inside the cross section of the beam which is subjected to two external moments as shown. For this, we will have to explain with the help of a diagram. Consider a bar which is subjected to axial loading and it is in the tensile form. The two forces which are equal and opposite are F and F dash, and they create tension within the element. If we try to look at the cross section, we find that this cross section creates a reaction which is equal and opposite to the action. Every section in this particular beam will create a reaction which will be opposite to the action, that is the force which is shown in this diagram. A similar thing has to happen for bending also. Now let us look at our slides again. The external moments are being applied and these external moments have to be resisted by the cross section, otherwise the beam will fail. Now to elaborate that, we have taken this section and removed the part CB of the beam. Now we see that the M dash is the external moment and the forces within the cross section arrange themselves in such a way that the net reaction that is created is a moment which is equal to the external applied moment. This is a very important fact to understand. The forces and stresses inside the beam are arranged in such a way that the net reaction is equal to an external bending moment. In order to make this interesting, you can pause this video now and try to figure out how the stresses can be arranged in a cross section so that the resultant force or resultant action is a bending moment as shown. Have you finished with the exercise? Well, let's give you another hint. Let us try to find the analogy of this in the very simple case of axial loading. Here we see that the beam or this member is subjected to a tensile force. Now, like in the previous case, if I take a cross section here and separate it, this is how it should look like. The cross section here would have a uniform stress. This uniform stress, sigma, multiplied by the cross sectional area A, would result in a force F. This force will be equal to the external applied force F dash. So now we see how the internal stresses, when summed up, create a reaction which is equal and opposite to the action that we have seen here. Now similarly, we have to try and find out what type of stresses will occur in a beam which can nullify the external moments. If you haven't got the answer already, here is the answer. Now this is the cross section and we want to analyze the stresses inside the cross section. Now I cut this half and I am drawing the diagram so as to show you the cross section. The external moment is equal to M and we have to try to find out what are the stresses within the cross section so that the reaction is also in the form of moment. Now please see carefully. If the bottom part of the beam is in tension and creates forces which are going outwards, and if the top part of the beam is in compression and creates forces which are going inwards, the resultant of that would obviously create a moment which will counteract this moment. Hence, the cross section of a beam has not only tensile but also compressive stresses. I will represent that with the help of plus sign as well as minus sign. So there is a distribution of the stresses from compressive to tensile within the cross section of the beam.